So this is an example. So we will see the how we can actually calculate the beta 0 and beta 1. So we saw the formula, but we will not do that by hand, obviously, right? So we will not just pushing the calculator like a 30-minute or 1 hour to find out what is the beta 1 and beta 2, beta 0. So we will use Excel, and so far because Excel will be good enough to find out all the regression analysis, because regression analysis is kind of the basic analysis. So we will see this one. So I posted also the Excel file you should be able to get, and then we can estimate. So since this is simple regression, we will choose only one variable, which is ROE. Depends on the ROE, average return on equity of the CEO's firm, and then CEO's salary will be calculated. Of course, the CEO's salary is not only depends on the ROE, but other things. So all other things will be melt into the like our error term. But what we want to capture is what is the effect of the ROE on the CEO's salary. Okay, and then you can find out the number. Intercept is a 963 and 18.501. So what this means is whenever your ROE increase by 1%, you can expect the salary of the CEO will increase by 18,501 dollar increase, because this is like 1,000 unit was a 1,000. Okay, what is the intercept? Is a 963 is the by calculation if ROI is 0 and how much will be the salary of the CEO. So of course you will not find any CEO who has a ROE 0. If ROE is 0, then you will be fired, right? However, what is the baseline? I mean, what is the how much you can get as like a starting point, and then depends on the ROI, salary of CEO will increase, but by how much? 18,500. But where is the starting point? That's the 963. That's what you can expect. Of course, the CEO salary is not only on the ROI, so the real observation of salary will be a lot different. But what will be the mean of the salary if their ROE is given? That mean should be calculated by this equation. Okay, let's assume this dotted line is a population regression line, and then by taking a sample we got our regression line. This is a fitted regression line. Problem is I don't know how close to the my line is close to the real population line. That's impossible to find because we don't know this line at all. Yeah, but we can estimate. So basically, we can create the confidence interval on the regression, and then we can say, I don't know. Just like our population mean, I don't know where's my population mean located, but we can create the confidence interval, and then we can tell if we do the same thing again and again, like 90% or 95% of the real case, real mean will be fall in between this interval. So we can do the same thing. I don't know where will be the real population regression line, but we can create the confidence interval so that if we do the same thing again and again, 95% or 90% time, our real population regression will fall in between the range. So we will see the line. So this is the data. So we just this table is just collected the ROE and then salary, and this is the estimation using model. from linear model. Okay. U hat is what? U hat is the difference. This difference is this one. This difference is this one. As you can see, some minus number and some positive number, right? So what we can expect is if you just add up, this should be expected of U hat should be 0. Okay, so it's like a 12. You can see the actual salary is just 933, but our estimation is 1,459. So predicted salary is higher, this much higher than the actual one. But some cases, real actual salary can be higher than our estimation. Hypothesis testing on the regression. So regression, you can have two different kind of hypothesis testing. Let's say we have a regression model, something like this, and then we can have a hypothesis test, t-test and f-test. T-test is the in simple regression model case, t-test and f-test is basically same, but t-test is each parameters. For example, in our case, it's for beta 0 and for beta 1 separately. But f-test is there the linear relationship between axis and y? So this is basically for beta 1. Then what is the difference? I mean, the t-tests do the beta 0 and beta 1, but f-tests do the beta 1. But what is the difference is actually, if you have a multiple variable, it will be different because the f is saying, is there any relationship? This is the f-test is trying to find out, is there any. Here, any means any variable. Any independent. So f-test is not only the one by one. If you have a multiple factor, then this will be something like that: x1 plus b2 x2, right? So f-test is trying to find out null hypothesis will be beta 1 is beta 2 is beta 3 is equals 0. So none of the my dependent variable, none of them has a linear relationship with the y. That's the f-test. So actually f-test is just trying to see our model at once. Take a look at everything, and then is there the real any of them, maybe just few of them has a linear relationship, few of them doesn't have a relationship, and so on, right? So I want to find out, this is typo, this should be there is a linear relationship. If beta 0 is not 0, beta 1 is not 0, then there's a linear relationship. Beta 1 is 0, which means there's no linear relationship. So f-test is a model itself as a 1, and t-test is for each parameter. However, our simple regression model, there's only one coefficient. So f-test and then t-test for the beta 1 will be the same. So if we reject using this t-test, then we reject the F test. Result will be exactly the same. Of course, what we are calculating will be a little different, but the result will be exactly the same because we have only one here. So as a model, all of them, there's only one. So actually, is it only one? All of this will be gone because we don't have a beta 2, beta 3, and so on. So this hypothesis, null hypothesis is exactly the same as a beta 1 is 0, same thing. That's why t-test and f-test will be the same for simple linear regression. So t-test, the t-test statistics is this one, okay? And then we have to find out what is the critical. And we're gonna, if you find this one, and we're gonna reject the H0. So we wanna see our value. No, you will get a beta 1, some number, but is it significantly bigger than 0? And this t value, so alpha is confidence level. And if n minus 2 is again the degree of freedom, right? You can look up the table and you can find the t value. Here, if you just Google the t-test table, you can see the first one. So I will just choose the first one. So actually, any table will do the job. Okay, so this is, as you can see here, I'm gonna enlarge. Right? So this is the one tail, this is alpha. What you want to see is alpha. But since our case is alpha divided by 2, so we will use a two-tail case, okay? So two-tail 1%, which is this is, okay, I will. As you can see, this is a one tail and two tail, right? So, okay, this is a 50%. 50%, this is when alpha is 50%. One tail is a 50%, which means it's this is 50%. So one tail, this is 50%, so the other 50%. That's why you can see here 90%. You can see, and also, so you have to find out the right t, and then you have to find the degree of freedom. When degree of freedom is greater, then you can just use some approximation. And this is about confidence level, and you can see you can find whatever you want. Okay, this is a critical t. Go back to our case. So once using the table, you can find this is the t critical t value from table. If t is greater than the critical t, then we can say this t is significant. Then we can reject the null hypothesis. Null hypothesis of beta 1 is 0. That's why we can conclude, if this is true, we can conclude beta 1 is not 0. So here, this is our estimation. Right? But what is the beta 1 here though? Of course, we don't know the real beta 1. But here, when we do the hypothesis testing, so we assume null hypothesis is true. And then what is the probability or what is the chance we can observe this kind of the data? If data is significantly weird, I mean very unlikely to happen, then we can reject the null hypothesis. Which means when we calculate the test statistics, this beta 1, we put beta 1 equals 0 because we are assuming null hypothesis is true. Right here, null hypothesis of beta 1 is 0. So that's why we put the beta 1 0 here, and then we can calculate. So what is SB1 is the standard error on the B1. So we already seen here, this standard error of the B1 is the what we calculate here. That will be goes to here, and we can tell, yeah, our t test statistics greater than the critical t value. Therefore, we reject, or if t is smaller than the critical t, then we cannot reject the null hypothesis, which means we cannot say there's a linear relationship between y and x. F-test is the mean square regression, mean square error, and then you just divide mean square regression by the mean square error. So what is a mean square error? Here is SSR. So again, SSR. SSR is the residual sum of squares, so this should be the just summation of the u square. And then SSE is the explained, so it will be the summation of y minus y hat. Of course, we have I here, right? And then number of independent variable is the how many independent variable you have. And then here the n is the n minus number of regression parameters. Again, this will define the degree of freedom. Because if you have a lot of the parameters, and when you calculate this y hat, we use that number of parameters, right? So that's why we subtracted that many. Okay, and then our test statistics calculate f will be calculated this way, and then also we can find the f from table. We can find the f. This is the critical f. If my f statistic value f is greater than this critical f, then we can reject the null hypothesis. Here again, the null hypothesis for the f test is usually for multiple regression. This should be something like this, right? Equals 0. That's why basically that's why it's different. But in this chapter, this is simple. This is basically the simple regression. So simple regression means there is only one variable. So we don't have this variable. So this is the same as this one. So exactly same as our t-test. Yeah, this is quite complicated, but even though I explained, Actually, when we use Excel, we will see the t-test and the f-test, but we don't remember all this calculation, and we will see what would be the, how can we tell, can we reject the null hypothesis or not? Easily, you don't have to memorize this formula. So t-test and f-test is a simple regression model. There is only one independent variable, right? So x is on one independent variable. That's why the t-test and f-test are exactly the same here. But usually f0 for the t-test is typically beta 1, beta 2, and so on is 0. But t-test is for one parameter each time. So each separate parameter.